Good afternoon, everyone, and thank you for choosing this presentation. My name is Andrej Chmelo, working as a software engineer at Broadcom. My full-time job is to be a contributor at Zoe, and this presentation I would like to share with you my experience during this project, how to secure a software in the open source. So, just a few words, the motivation, the beginning. How you want to secure your software, and mainly because not securing it is expensive. As you can see, or if I believe everyone knows, running any unsecure software can lead to a lot of problems, starting with data breaches when some unauthorized attacker is able to get your data, or you can directly lose money through some transactions. It can lead to reputational damage or operational disruptions, which for some businesses cost a lot of money for every hour when your service is not available. And all of this means that you need to take a proactive approach. And so let's take a look how to do that. For the demonstration, I took as an example a project that is based on Spring Boot. It's widely used technology. It's also open source. There is a very handy tool on the internet that you can just take, click fill in some details, and it allows you to very quickly start a new project. And if you want to build just the REST API, you just need one dependency, hit generate, and this is what you get. So you'll get a basic Gradle project with some main Java class. You have just one implementation dependency that you can see in your Gradle configuration. And so you can contribute with others. You want to version your project, you need to initiate a new Git repository. So this is the minimum that you need when you are starting a new project. But what exactly it is and what do you need to solve from this starting point? You need to somehow ensure that the quality of your source code is as high as you would expect. You need to know what are the external dependencies that you have in your projects. I was showing you that there is just one implementation dependency, but in reality, Spring has this Spring dependency has up to 30 transitive dependencies that you get downloaded into your project. You don't have any authentication authorization for your REST endpoints, so anyone can use them. And all your communication over the internet is unencrypted, so you're doing the plain text communication, which everyone can consume and read. So now let's talk what it means to build a secure software, how to bring the security in this process. If you don't know where to start, it's always good to look over the internet and what are the best practices, because you don't need to reinvent the wheel. You just need to learn from others that in the past had to solve these issues. And such an example is a framework called Secure Software Development Framework. It's from National Institute of Standards and Technology. And they compiled a set of best practices from documents that were produced by organizations such as OWASP, BSA, or SafeCode. And they created this framework for you. and put all these best practices into 4 groups, starting with how to prepare your organization, how to protect your software, how to produce well-secure software, and with how you should respond to vulnerabilities. And I will be talking about these groups and how we are implementing them, or how we are using these practices from them. So the first one is how to prepare your organization. When there are a lot of people working or within the company, they need to know what to do. So this group is talking about how to prepare these people, prepare the processes, prepare the tools for development, so they can support you. It's talking about roles. You need to make sure that everyone in the organization knows his or her role and needs to know what are the responsibilities of that role. Such an example is security champion, but also every other role in software development lifecycle needs to be specified, and they need to know their responsibilities. And you need to prepare the environments for this process. This environment needs to be separated and well protected, as you would protect any production environment. So it means each environment needs to have their multi-factor authentication, needs to be in a separated network, and protected. Next thing is how to protect your software. You need to make sure that all access to the source code and to the results of those, or to the builds of those code are protected, and are protected from any tampering. As an example, you see on this slide is taken from API layer repo from Zoe. You can see that all commits in this repository are signed, they are verified, so you can be sure that only verified contributors were including their code into the main branch, which is then used to produce a software. You should have some kind of a branch protection, which is not built into any Git tool, but it's always a feature of some source code or some version control platform, such as GitHub or Bitbucket. And it's always a good practice to have at least one approval for merging code. But I will talk more about code reviews later. You should archive the releases for later analysis if something happened, and each release needs to be able to be validated for the integrity. This is very important for the consumers of the software. And how that looks. Each package or binaries that are delivered to customers or to the consumers of your software needs to be signed cryptographically using some verified, or using some certificate verified, issued by some verified certificate authority. So when they download your package, they can use tools to validate the integrity of that software, so they can be sure that it's not coming from some attacker. and provide some hash so they know that the download of that software was successful and they can use it. How to produce a well-secure software? It started with secure design. That design needs to be taken in the context of where the software will run, what is the software about. The design would be different for some database application, and it would be different for API gateway because they are running in different environments. The attack vectors are different for them. So this needs to be taken into account. Coding itself, or developers that are working on the source code, needs to work in the mindset that the security is integral part of the development and needs to follow the secure design that was initially set. And at the end, once you have this code, you need to be able to identify the vulnerabilities and verify the compliance with what you set at the beginning. This is called code review, but the code review is just the last step in this process. But it starts with those coding practices that I was talking about. And you can see there's just a few checkboxes for secure coding practices. But on the internet you can find way more. You can find 200 pages cookbook from OWASP that is describing how to securely code. But you should take care about, for example, data validation. This again is maybe more related to database application than it's for the gateway. But another thing, authentication is a very important part of every application which has some public endpoints. Logging is quite interesting topic, and it can be even dangerous if it's not done right. It's one story from one regional bank from Europe that went down because of a null pointer exception in the logs, so be careful about that. And the configuration needs to be secure as default, so when someone installing your product, they don't need to change anything, but it's forcing them to run the product with certain level of security. Once you have something, you have some code base, and the project is growing, it's getting more and more dependencies, and it's not that easy to just handle everything by human eyes. Then you should use some tools for static code analysis, something like Sonar Cloud, which is scanning your code, your source code, without running it and providing you hints in case that there was some issue found. But it's not perfect. It can help. It can produce a lot of false positives, but it's a pretty handy tool. Maybe the more important thing is software composition analysis. I believe you heard a lot about it today. It's all about the bill of materials of the software. And basically what it's doing, it creates this bill of material for you, which is a list of all the dependencies, like everything what your software contains. Then it's comparing it with some database of known vulnerabilities. And the result is set of security and legal violations of your software. So then you can act on this. You can either update those dependencies. You can, if not possible, you can remove them or replace with something else if there are no updates. And the same goes for legal vulnerabilities, because you should be using only software that allows this from its license. Why it's important to do these scans? As you can see on the graph, each year the number of found vulnerabilities are growing, and is growing by large. For the last quarter, it was more than 7,500 newly found vulnerabilities, which is roughly 20 a day. Many projects, for example, use this Tomcat, which almost each month got some new vulnerability. That's because of the what it is, because it's a server, so there are a lot of people using it. It's an environment that is really vulnerable to security issues, so it's always good to verify these things. And if your software is not vulnerable now, it doesn't mean that it's not vulnerable, it's just the CV is not there yet. Important part of this life cycle, of software development life cycle, is testing. Before you can release, before you can even merge the code into the branch, everything should go through certain level of test. So you can start with the automated test, which is unit test, functional test, or integration test. This must be a requirement for any code to be merged. And it should validate any requirements from the point of view of security. Then there is the dynamic security testing, which is called also black box testing. There are very convenient tools available as a GitHub Actions, for example, that you can just use and run against your web page. But be careful to not run it against your production web page, so it can cause some disruptions. And the last one is penetration testing. This one is, again, manual task. You can hire some company, or you can have your own department specialized into this testing, and it can help to find security holes by just trying to breach your software. So you are doing all these best practices, but at the end you need to know how good are you doing. So you need to do some kind of a validation of that process. So for this, it's very important to collect the metrics from your development lifecycle. You need to know what are the baselines, where you want to go, so you can compare those two situations. You need to have the reporting, because the data without analysis and the reports, it's not useful for you. And you need to use these data or these results for continuous improvement in the development. And because all the attackers and basically people that are trying to attack your software are improving every day, are more and more threats, you need to do the same. You need to keep learning. You need to stay informed. You need to stay informed about the regulatory changes. A lot of news every day and follow some blogs that are talking about the security, which can serve as a valuable source of information, and engage with some partners, because no one knows everything, and this is a huge benefit of working in the open source, working in the community, because you can exchange the knowledge among the partners in the open source. So, yeah, quick. So to wrap it up, what I was talking about, as I said, it's expensive not to care about your security. It will potentially, or most probably, would be more expensive if you don't care. It would cost you a lot of money, and it can cost you data, a lot of resources. You need to engage everyone in the organization. It's not just only for security champions or security experts. Take some already existing frameworks, take the tools that are available on the internet or the open, and improve. Don't stop with improving the security. And that's it from my side. Any questions?
So one question, have you mentioned SBOM?
Mm-hmm.
How are you using the SBOM? If you export the SBOM, how are you actually using that?
Yeah, we are using it in the tools that report you what are the vulnerabilities there.
Which
So,
tool are you using?
yeah, we are using, one is the dependency check, this, the open source one.
What is the name? Do you know the name?
It's a Gradle plugin, open source version. So it's, I'm not sure who is the owner of this tool or is the maintainer. It's,
yeah, if you look up the dependency track, it's an open source project. It consumes SBOMs. You can even do your SBOMs and correlate the vulnerabilities of an open source project.
Dependency track?
Yeah.
Dependency track.
Is there a way for us to get access to this thing like this?
sure, I believe I have uploaded it somewhere. I believe I uploaded it to the in the schedule. Yeah, so that it's there. Okay, thank you.